So I just wanted to start off with looking at the difference between a bar chart and a histogram. You will already be familiar with bar charts where you have what is called discrete data along your x-axis. What I mean by discrete data is that you can actually categorize the data. So for example, in this particular example, you have January, February, March, April, May, June, July, August. So that data can be easily categorized. And in a bar chart, there are gaps between each bar. And you will notice that each bar has an equal width, so it's all the same size. It may not be the same length, but the width of it, how wide each bar is equal in a bar chart. This changes when you have what is called a histogram. Now, histogram is used to represent continuous data. Therefore, there is no gaps between each bar. So that's the first key difference, no gaps between the bars. And the second difference is that you can see that these bars have all different widths. Yes, they're all different heights, similarly to here, but they are not all the same width. That is the main property of a histogram, is that you can have different width of bars when you plot it. Another difference is that in a bar chart, we just plot the frequency against the category. In a histogram, you need to work out something that is called frequency density first. Once you've worked out your frequency density, you then plot that against whatever data you've been given in the question. So I'm now going to go through an example with you just to explain how to work out each step. So you will be given a table and you will be given a frequency. So this might represent the price of something and how many items cost that much. So you first of all need to have a column in your table that tells you the width. Now the width is told by the inequalities. So as you can see, this starts from 0 all the way to 5, so that means I have a width of 5. So you're working out the difference between these two numbers. The next one, 5 to 10, is a difference of 5 again. 10 to 20 is a difference of 10. Now remember, you can have different widths of bars. That's the main property of a histogram. And the final one is 20 to 40, so that has a width of 20. So 40 subtract 20 is 20. Remember, frequency density is your frequency divided by your width. So 40 divided by 5 is 8, 60 divided by 5 is 12, 60 divided by 10 is 6, and 40 divided by 20 is 2. Now what you need to do next is plot your frequency density on the y-axis and your width on the x-axis. Once you do that, it's going to look like this. Okay, so the question was the number of books per pound. So 40 books cost between £0 and £5, 60 books cost between £5 and £10. And this represents that. You can see the width that you worked out is on my x-axis. So I've got 0 to 5, 5 to 10, next one is 10 to 20, and 20 to 40. And the y-axis is the frequency density. So you can see that I need to go from 2 all the way to 12. Now I need to obviously start from 0 and make sure that I cover a minimum of 12. This graph didn't necessarily need to go all the way to 20. They could have gone to 15, for example. So they've just plotted, well, the first bar is 0 to 5, and it has a frequency of 8. So 0 to 5, 8. 5 to 10, 12. 10 to 20 is 6, and 20 to 40 has a frequency density of 2.